Welcome back. In the last video about section 2.4, I'm going to talk about this kind of algebraic calculation of one-sided limits. So in this question I'm asked, hey, if I take the limit as x goes to 4 from the right of this thing, what's it going to be? And it's useful here to go back to our old-fashioned way of doing this, which is to say, okay, what's happening in the numerator? It's going to 4. What's happening in the denominator? It's going to 0. And so I see, hey, this thing wants to be 4 over 0. That's not good. So that tells me this answer is going to be some flavor of infinity. So as soon as I see that this number is 0 and this number is not 0, this tells me the answer is going to be plus or minus infinity. So how do I decide which one it is? Well, I have to think about what the fact that I'm approaching this from the right means. It means my input is a little bigger than 4. Okay. And so if I take a number that's a little bigger than 4, and I subtract 4, what do I get? Well, I get a really tiny number, one that's really close to 0. But there's a piece of information we didn't use, because if the number is a little bigger than 4 and I subtract 4, I get a really tiny number, but I get a really tiny positive number. And I'm going to denote this in kind of a weird way. Namely, I'm going to write this as a plus 0, to emphasize that this is a really tiny number that is positive. But if I take 4 and I divide it by a really tiny positive number, well, this is a positive number divided by a positive number. It's going to be positive. And I already know I only have to decide if it's plus infinity or minus infinity. But it's positive, so it's got to be plus infinity. And that amounts to being the story of what we're going to do here. So let's see what happens on the other side. It's the same thing. So I know that this is still going to end up saying, oh, it's about 4. This is going to say it's about 0. Okay, but I want to answer the question, what kind of 0? Which is a weird question to ask. Okay, but now I'm looking at a number that's a little less than 4. So if I had a little less than 4 cookies, and someone took 4 cookies from me, then I would have a negative amount of cookies, which maybe doesn't make a lot of sense. But I'd end up having more cookies taken from me than I had, so I would end up owing cookies. Cookies was not a good way to describe this. But anyway, my number's a little less than 4, so when I subtract 4 from it, I get something negative, and so I'm going to put a minus sign here to commemorate that. Okay, and so this is a negative 0. Okay. Again, because this number is 0 and this number is not, I know the answer is going to be plus infinity or minus infinity. But now I have a positive 4 divided by a negative 0. That's going to give me a negative infinity. Okay. Again, just because a positive divided by a negative is going to be negative. Again, I want to think about what the story I just learned tells me about the graph of this function x over x minus 4. Namely, it tells me that at 4, so this is the input 4, on the right-hand side, that is on this side, it ends up running off to positive infinity. That is, again, in the direction of the plus infinity on the output axis. Okay. And on the left-hand side, it ends up running off towards minus infinity, in the direction of the minus infinity on the output axis. Okay. And so it is telling me this particular shape is the shape of this particular explosion that happens when I try and divide by 0. Because when I plug in 4 here, I get 4 over 0. Okay, so let's do a couple more examples of this just to make sure that we're comfortable with everything that's happening. So we're going to look at the limit as x goes to 3 from the right of this thing now. Okay, this is going to be plus 13. This is going to be about 0. But the thing I have to decide is whether I want this to be a positive 0 or a negative 0. And what I have to take into account is that this plus sign tells me the number I'm plugging in is a bit bigger than 3. So if I start with 3, and I'm not going to do anything with cookies this time, I promise. If I start with 3 and I subtract a number that's a bit bigger than 3, what's going to happen? Well, I'm going to get a negative number, right? Okay, because I subtracted more than 3 from my starting 3, so I went past 0 and ended up in the negatives. And so that plus 13 over negative 0, that tells me that this limit is going to end up being minus infinity. Okay, how about the limit as x goes to 2 from the left of 2x minus 6 over x minus 2? So here the numerator is going to be about negative 2. Okay. Notice for purposes of the numerator, this from the left doesn't matter at all, because if my number is a little bigger than 2 or a little less than 2, 2 times a number close to that, minus 6, is still going to be really close to minus 2, even whether it's a little bigger or a little smaller. All I care about is that it's negative. Whereas this denominator here, now I'm looking at a number that's a little less than 2. And so if I have a number that's a little less than 2, and I subtract 2 from it, what's going to happen? I'm going to have a negative number, right? It's going to be a really tiny negative number, but it's still going to be negative because I subtracted more than I had, because I started with a little less than 2 and then subtracted 2. And so that's why I'm going to write a negative 0 here. And so the numerator is going to be about negative 2. The denominator is going to be about negative 0. And so that means that this limit is in fact going to be positive. And because it's a non-zero number over a 0 number, it's plus infinity or minus infinity. And so since it's positive, it is definitely plus infinity. Okay. So let's do one more example, and I'll warn you in advance, I'm going to do it from both directions, so don't get too excited that it's going to be over yet. We've got here the limit is x goes to 3 from the right of 2x minus 7. So what's happening to the numerator here? It's going to be minus 1. What's happening to the denominator? Well, x is a little more than 3. So when I take a number that's a little more than 3 and subtract 3 from it, it's positive. I've got some cookie crumbs left. And so then I square this tiny positive number, and I still get a tiny positive number. And so this thing here, it's going to be a positive 0. Okay. And so again, non-zero number over positive 0 number. That means this is going to be either plus infinity or minus infinity. But I can read that off because this is negative and this is positive. So this is going to be minus infinity. Okay, what if I went from the left instead? Well, this is still going to minus 1 because I didn't change that part. Let's think through this piece now. I know it's going to 0, but I need to decide whether it's going to positive 0 or negative 0. So my x is a little less than 3. That's what this minus is telling me. And so if I take a number that's a little less than 3 and subtract 3 from it, I get something negative. I get a negative tiny number. But then I square it. And so if I square a negative tiny number, what do I get? I get now a positive tiny number. Because anytime you square anything, it becomes positive. And so this is a plus 0 here. And so this limit ultimately ends up also being minus infinity. So if we want to draw a picture of what that looks like, we've got our function here. We've got our input at 3. And on both the left and the right of 3, our output spikes down towards the minus infinity on the output axis. And now, in this case, it's even fine to actually say the limit as x goes to 3, no jewelry, of 2x minus 7 over x minus 3 squared is minus infinity, because both the left and the right pieces go to minus infinity. Which you'll notice most of the previous examples we've done have not worked that way. So for example, this one, they went in opposite directions. So we couldn't say anything meaningful about the limit as just x went to 4 of this. Okay, but here, since they both do this, you can say this if you want, it's fine. All right. We're going to wrap up there for section 2.4. I'll be back in the next section, 2.5, to put together all of these pieces about horizontal asymptotes and vertical asymptotes and limits from the left and limits from the right and limits to infinity and of minus infinity, and just put together all of these pieces so we can understand what these graphs of rational functions look like. But that's all for now. I'll see you next time.